Hello and welcome to Mr. Tompkins EdTech. This is the third video in a series looking at the Casio graphical calculator and how we can use it to solve exam style problems taken from real A-level S1 statistics and probability papers. Students following an IB mathematics or biology course are welcome to follow along too, as the style of questions will be very familiar. In previous videos we have looked at finding mean and standard deviation, and we've also looked at the Pearson's PMCC. This time I'll be showing you how to find least squares regression lines and how to decide between y on x and x on y. We'll also be looking at using regression lines to make estimates and discussing the reliability of these. Least squares regression is essentially a technique for finding the equation of the line of best fit. In GCSE we just had to put our ruler on a scatter graph, wiggle it around a little bit until it looked right, and then draw it on. So not very mathematical really. Now, least squares regression imagines drawing squares from the plotted points to a line of best fit angled through the centroid or x bar y bar coordinate, and then mathematically jiggling this about until the areas of all the squares are minimized. This graph shows a y on x regression. You can tell because the squares are formed by dropping lines vertically from the plotted points to the regression line. You can see as I angle it, those squares get larger and smaller, and we're aiming to get them all as small as possible so that when we add them up, the area is minimized. Now in x on y regression lines, the squares are formed slightly differently, this time by drawing horizontal lines from the plotted points to the regression line. But again, the process aims to minimize the sum of these areas. These two types of squares give slightly different values, resulting in two slightly different lines of best fit. We will need to know when it is appropriate to use one or the other of these lines, and examiners will often probe our understanding of this during the exam. So let's get started. This is a continuation of the question in the last video concerning itself with the City Council's attempt to reduce traffic congestion by charging motorists to enter the city centre. The council started with a charge of £4 in the first year and increased it by £2 in each subsequent year. We already entered the data into our calculator in the last video. If you're not sure how to do this, then pause this video and go back to the one on PMCC and watch that one first. There is a link in the description below, or you can tap on the card on the screen. Now, before we calculate anything, we first need to decide on the appropriate regression line to use, which means choosing between either y on x or x on y. To do this, we have three checks we need to make. 1. Check the context. 2. Check the scale. And 3. Check the lookup value. Firstly, let's check the context. Which value is controlled or set, and which is dependent or measured? Now in this question, the council has direct control over the amount charged to enter the city. It cannot directly control how many vehicles actually turn up in the city on any given day, but they can certainly measure this with traffic cameras and sensors. So the charge or x value is the controlled variable, and the number of vehicles or y value is the dependent variable. This tells us we need to use the y on x regression line in this question. The context is clear and there is no need to carry out the two further checks. If in another question it wasn't very clear from the context which variable was controlled and which was dependent, you can move on to your second check, which is check the scale. Does one of them consist of nice whole numbers which are ordered and incrementing steadily, and is there one with lots of decimals jumping about the number line? Here the charges are all whole numbers going up in twos. It is clearly controlled. The number of vehicles are unordered decimals, so these are measured dependent values. Now, if and only if you cannot discern the controlled and dependent variable from either the context or the data, then there is one final check to make. 3. Check the lookup value. In the question, we are being asked to find the y value or number of vehicles when the x value or charge is £20. So in the absence of any other clues, if you are finding y from x, you should be using y on x. Now, all three of our checks are telling us to use y on x here, but remember these checks are in order of importance, so if they did disagree with each other, context is the most important and overrules all other considerations. So we want to use the y on x regression line, which is given by the formula y equals a plus bx. We will need to find b first, the gradient of the regression line. Now the calculator generates this value for us, but we need to get all 5 marks, so we're going to have to show some method. The calculation for b uses the same SXX and SXY formula we used in our last video for finding PMCC. The calculator doesn't generate these directly for us, unfortunately, but it does give us the totals required to find them. If they are not given in the question, you can find them by pressing F2 for the calc function, followed by F2 for 2 variable calculations. So copying them onto our paper, we can now substitute them directly into the formula for b. As with PMCC, we won't actually type this expression into the calculator. There's no point, as it already knows the value of b. On the calculator, we can find this by pressing the F2 calc function, F3 for regression, F1 for linear regression, followed by F2 for y on x regression. Now obviously F1 is going to give us the other sort of regression, the x on y regression line, so you'd have to press that one if that's the one you were doing. Now you can see we have the values displayed for a and b along with our r value, which we already know is PMCC. So let's write down the value for b and also our method for finding a. Now we can now write down the full equation for the y on x regression line given by y equals a plus bx. Now we have the equation of the regression line. Exam questions will often go on to ask us to use it to estimate certain values. Here we are asked to find y when x is 20. So simply sub this into our equation to find our value of y. Don't forget to check the units carefully. Here y is measured in millions, so the correct answer is 1.42 million vehicles. Now the last part of the question asks about reliability. There are 2 factors affecting reliability, and you will need to reflect on these and make a decision. Firstly, strength of correlation. For the estimate to be reliable, there must be high correlation, so anything above 0.9 for positive correlation or below minus 0.9 for negative correlation. In this question, we have negative correlation and calculated PMCC to be minus 0.96, so we've clearly got high correlation here. The second consideration is whether the value we are looking for is within the given range of data or outside it. If it's within, we are interpolating and the estimate will be reliable. If the value we are looking for is outside our given range, then we are extrapolating and the estimate is unreliable. Now here, 20 is just outside the data given, so technically we are extrapolating, indicating the estimate might not be reliable. But because correlation is so high, and because it is only just outside the range, the correct conclusion would be that it is reliable. So I'm going to write correlation is high, minus 0.96, and is just outside the given data, so the estimate is reliable. Now, let's review the marks for our work. We have chosen the correct regression line, earning our first mark. We gain a method mark for the substitution and an accuracy mark for finding b, a second method mark for our calculation for a, and a second accuracy mark for the correct equation. For the second part of the question, we gain a method mark for subbing 20 into the equation and an accuracy mark for the correct answer. The final 2 marks are B marks, which means they are independent of method or awarded for correct statements. We earn 1 for high correlation and another one for just outside our range in our conclusion. Now note that often mark schemes will award you the marks either way, as long as you give a valid reason. So here, saying no because it's extrapolation would still earn you the marks. So that's all for this video. You should now know how to choose the correct least squares regression line and to use your Casio graphical calculator to find its equation. You also now know how to decide whether estimates found will be reliable or unreliable. So please like if you found it useful and leave a comment if you have any questions or suggestions. In the next video in the series, we'll be taking a look at discrete random variables and how we can use the Casio graphical calculator to find probability ranges and thus avoid having to use those strange throwback lookup tables. So please hit subscribe so you'll be notified of this and any future uploads. Thanks for watching, and I hope to see you next time.